Hello everyone, so in today's class we are going to discuss question number 15 of ISS of the year 2024. It belongs to your set A. You can see the question on the screen. This question says that x1 and x2 are your ID normal 0, 1 variate. Then the characteristic function of x1 into x2 you have to find. Okay, so everyone, I'm just going to assume that u is representing x1 plus x2 and v is representing x1 minus x2. So easily from here we can say that u is following your normal distribution with mean 0 and variance 2. In the same way, v is following your normal distribution with mean 0 and variance 2. Okay, so this is a very easy step. Now I'm just jumping a one step forward, and after that, finding the value of x1 and x2, we have to multiply it. And after multiplying these two values, I will get 1 by 4 u square minus v square. Now I'm giving this as a homework, or right now you can do it. You have to find the value of x1 and x2. And if you're facing any difficulty, for that you can join me live classes. I provide live classes on Google Meet. If you want further detail, you can contact me on Instagram as well as on WhatsApp. You will get my number on Instagram, okay, as well as in the bio of the YouTube. So now, after finding the value of x1 and x2, what we can do? We just have to find the characteristic function of x1 and x2. That means we have to find phi x1, x2 of t. So as of using formula, what I can write? I can write expectation e to the power I t x1 into I t x2. Okay, now you know already what is the value of x1 and x2. We derive in the above line. We have expectation of e to the power I t. We have this 1 by 4 and u square minus v square. So I have written this value from the above line. Now you know x1 and x2 are independent. Okay, so obviously u and v are independent. So using the property of independence, what I can write? I can write expectation of e to the power I t by 4, and this is your u square, then into expectation of e to the power minus I t by 4 and v square. So using the property of independence as well as the property of the characteristic function, I can apply expectation on both sides. Okay, so after applying expectation on both sides, now what I can do? I just have to derive that which distribution u is following here. So right now you can see this is the u which is, let me show you. So this is u which is following normal 0, 2. This is v which is following your normal 0, 2. Now you can see here, if I'm going to show you, so u is following your normal distribution with mean 0 and variance 2. So if I'm going to subtract its mean, subtracting its mean from here and dividing with variance, root of variance, which is root of 2. Now this will follow your normal distribution with mean 0 and variance 1. Now it became the standard normal variate because we have subtracted its mean and divided by its standard deviation. Now if I'm going to square it, that means u minus 0 root 2 whole square. Now it will follow your chi-square distribution with 1 degrees of freedom. So from here what we are getting? U square by 2 is following your chi-square distribution with 1 degrees of freedom. Now coming back on the question. So now here you can see this is u square, and now we can take u from the denominator. So this is your expectation e to the power iota t by 2, and this is your u square by 2 which is following your chi-square distribution, and expectation e to the power minus iota t by 2 and v square by 2. V square by 2 will also follow your chi-square distribution. Okay, now what we can do? Now you can see we just have, like, this is, suppose this is a constant term. Now we have to find the characteristic function of this u square by 2. Okay, that means this is the variable which is following your chi-square distribution with 1 degrees of freedom. So first of all, I'm just going to tell you the characteristic function of chi-square. So see, when x follows your chi-square, distribution with 1 degrees of freedom, so its characteristic function or its MGF can be written as 1 minus 2t to the power minus 1 by 2. When we are finding the characteristic function, what we can write? 1 minus 2 iota t to the power minus 1 by 2. So this is what we can write when we are going to find the characteristic function. Okay, but right now at the place of t, at the place of only iota t, what we have? We have iota t by 2. Okay, so now I'm just going to write here the final value. So you can see I just can write 1, like inside bracket 1 minus 2 times, I will write then iota, then t by 2 whole to the power minus 1 by 2. So I can cancel out this 2 from 2, right? And now see, it has minus iota t, the second part. So what I'm going to write? I will write down the, like, we will get the same answer, but in the middle we will have the positive sign. So plus, we have 1 plus iota t to the power minus 1 by 2. Okay, so this is what we got. Now from here you can see we have whole power minus half. So inside bracket what I can write? 1 minus iota t, then into what I can write? 1 plus iota t whole to the power, what I can write, minus half. Now simplifying it, what I will get, 1 square is 1. Then what I can write, minus, then iota square, the value of iota square is your minus 1. So minus 1 into this minus become plus, and we have this t square, whole to the power we have minus this half. Now from here you can see what I can write. I can write 1 whole upon 1 plus t square. So this is the final answer that we are getting, and you can see here in this question, this is given in the option number C. So that means option number C is the correct option. So thank you everyone for watching this video. Have a nice day.